All right, we're going to solve a physics exercise about resistors. We're going to start with the first question. This one takes some time, but it's pretty easy if you pay attention while solving it. First up, so the question is, express the equivalent resistance of the resistors in the diagram in terms of one of them, knowing that all these resistors are identical of resistance R. So in this circuit, all these resistors are identical. Their resistance is R. We need to figure out what the equivalent resistance of the circuit is. I'm just going to sketch it out onto this. We've got R, 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 and R. Now, it doesn't matter what this is connected to at the end because we're just trying to find the equivalent resistance right here. So we want to start off by separating it into parts. We can see pretty quickly that these two resistors are in series with each other. So if you guys remember how to solve equivalent resistance in series, it's just the resistance of one plus the resistance of the second. So what this is our equivalent of these two is equal to R plus R, which is equal to 2R. So now the nice thing about this is that the circuit can now be redrawn like this. And through this redrawing, we can see that these two are in parallel. Parallel, we know, can be solved like this. 1 over R equivalent is equal to 1 over R plus 1 over 2R, which is then equal 1 over R equivalent is equal to 3 over 2R. So R equivalent of these is 2R over 3. Now this once again can be redrawn to look like this, and these are all pretty clearly seen in series, so we can solve it like this. R equivalent of the total thing is R plus 2R over 3, which is equal to 8R over 3. So that is how you solve the first exercise in this long exercise list. Next, we're going to solve this exercise. This exercise, let me read it out to you guys. 5 resistors are connected to an ideal battery of potential difference 12 volts as shown in the adjacent circuit diagram. They give us the given of the 5 different resistors. They give us the resistance of those 5 resistors. The first question is verify that the total resistance of the circuit is R equivalent equals 80 ohms. Now to solve this, we once again need to split it up. We can start with these two. These two are pretty clearly in series. So this is how we're going to solve it. All right. So R23, because that's what those two are. R23. Let me put this here so you guys can read the given. So R23, since they're in series, is R2 plus R3, which is 50 plus 10, which is 60 ohms. Now we can see that R23 and R4 are in parallel. So R234 is equal to R23 times R4 over R23 plus R4. It's going to be 60. R4 is 30, so 60 times 30 divided by 60 plus 30, which is equal to 20 ohms. Now we can tell that R1, R234, and R5 are in series. So this is how we would solve it. So R equivalent is equal to R1 plus R5 plus R234. which is R1 is 40, R5 is 20, and R234 is 20. All these together add up to 80 ohms, which is verified. Quick solve. Next. Deduce the intensity of the current sent by the battery. So intensity of the current is this I right here. We need to figure out how much it is. This again is a pretty quick solve. To solve it, you just need to use Ohm's law, which obviously we know, we've learned it. So we're going to solve it like this. So first of all, by Ohm's law, U equals Ri. So I is going to be equal to U of the battery, which is UPN, over the total resistance, which is R equivalent. UPN was given to us because we know voltage of the battery is 12 volts. So UPN is going to be 12 volts divided by 80 ohms, which will get you to 0.15 amps. So that's the intensity of the current of the battery. Next, they asked us to determine the voltages UPA, UAB, and UBN. PA is from here to here, AB is from here to here, and BN is from here to here. For all of these, we're just going to use Ohm's law, so I'm going to solve it really quickly so you can see. We're just going to use the equivalent resistance of each one of these and the total current, because the current goes through here, and then all of this adds up to the current, and back out here's the current. So we're just going to use equivalent resistance of each part of these and the intensity. So let me just solve it really quickly. So UPA is equal to R1 times I, which is 40, times 0.15, which is 6 volts. UAB, same thing, R234 times I, which is equal to 20 times 0.15, which is equal to 3 volts. And then UBN equals R5 times I, which is equal to 20 times 0.15, which is equal to 3 volts. There you have it. That's how you solve that part of the question. The next question, the next part of the question says, deduce the dissipated powers PAB, and PBN. So to find the power, P equals UI, which we have both of. We just calculated the U and we have the I. So we're gonna solve that. So P of PA is equal to UPA times I, which is going to be equal to 0.9 watts. PAB is equal to UAB times I, which is equal to 0.45 watts. And PBN is also equal to UBN times I, which is going to be equal to 0.45 watts as well. This is just based off of what we've solved previously. Now, they ask us, verify that the total power dissipated by this circuit is equal to the power delivered by this battery. So what they're telling us to do is, first of all, calculate the total power by the circuit, and then calculate the total power by the battery. We need to verify that they're equal. So to calculate the total power in the circuit, we just need to add the powers that we came up with previously. So power total is equal to 0.9 watts plus 0.45 watts plus 0.45 watts, all of which we just calculated in the previous exercise. So it's going to come out to 1.8 watts. Now, we need to calculate the power delivered by the battery, which is P of Pn, because that's what the battery is, Pn. So we're just going to use the voltage of Pn, which we already know is 12 volts, based off of the given. so 12 volts. And then we need to use the current, which is 0.15 amps, which will come out to 1.8 watts. So 1.8 is, oh, that's an 8. 1.8 equals 1.8. So verified P total equals P of Pn. That's how you solve that part of the exercise. Next, they told us to calculate I prime and I double prime. I prime goes along R2 and R3. I double prime goes along R4. So the way to solve this, again, just Ohm's law. So I prime is going to be equal to the U, AB, divided by R23, because as you can see here, it goes R23 like we said. So R23, which is then 3 volts divided by 60 ohms, which is 0.05 amps. And I double prime goes along R4, so it's going to be UAB divided by R4, which is 3 volts over 30 ohms, which is 0.1 amps. And if you're not sure about this answer, one thing you can look at is, remember how we said that the total current is 0.15 amps? So 0.15 is splitting into 2 parts, into I prime and I double prime, which means I prime plus I double prime should be equal to the I total. So if you're just unsure about the answer, you can add the two together, 0.1 plus 0.05, which comes out to 0.15, which just helps you make sure that you've got the right answer. And the last question is, determine the electric energy supplied by the battery during 1 minute. So to be able to solve this, we just need to use the formula that says E, which is energy, electric energy, equals power times total time. So power, we have that already, we calculated that up here, is 1.8 watts. And then they told us time is 1 minute, but we know that the SI unit of time is seconds. So we need to get the time in seconds, which is a pretty easy conversion because 1 minute is 60 seconds. So the total time is 60 seconds. So when you multiply these mabad, you get 108 joules. That's how to solve that exercise.